In this video, I want to look at solving trig equations, and I'm going to do this through numerous different examples of different things that might happen. As you're solving trig equations, there's a few things that you should make sure you're comfortable with. The first thing you should know is the trig and value relationships in the first quadrant, so you should know the basics of your unit circle in the first quadrant. You should know how the unit circle works so you can fill in the rest of it and read it appropriately. You should be comfortable with the relationships between radians and degrees and switching between the two. And finally, you should have a pretty good idea of what the graphs of different trig functions look like, at least for one period of the trig function, since they do repeat indefinitely. So let's start to look at some examples. Here I have cosine x plus square root of 3 equal to minus cosine x. The first tool for us to have in solving these trig functions is combining like terms. Just like I can add 4x to both sides, I can add cosine x to both sides to get all of my trig functions, all of my cosines together. Over here I now have 2 cosine x, since I have 2 cosines, plus the square root of 3. On the right hand side I have 0. I can then subtract the square root of 3 from both sides. That gives me 2 cosine x equal to minus root 3. And then divide both sides by 2 to get cosine x equal to minus square root of 3 over 2. So now I need to know what angle has a cosine of minus 3 pi over 2. So now what I really want to know, what is arc cosine of minus 3 pi over 2? Well, if I think about my unit circle, I'm just going to draw the first quadrant, or at least a rough sketch of it. Not a great circle, but that's okay. Down here at 30 degrees, or pi over 6, we have the point square root of 3 comma 2, square root of 3 over 2 comma 1/2. But I want negative 3 pi over 2. So what I need to do is go up and over to this point over here. So what I've done is I went all the way around to my full pi and then back up pi over 6. So x would be equal to pi minus pi over 6, or 5 pi over 6. If we have access to the full unit circle, we could have found where the first coordinate was negative 3 pi over 2 and saw that this was negative pi over 6, and saw that this was 5 pi over 6 very easily. But if we only know the first quadrant, this is how we can build out the rest of it. Next, I'm going to look at 4 sine squared x minus 3. Well, let's get the trig function by itself. So now I have 4 sine squared x equal to 3. Divide both sides by 4. And sine squared of x is equal to 3 over 4. We can take the square root of both sides, but we have to remember that when we take the square root, we take plus or minus. So I have plus or minus the square root of 3 over the square root of 4, which is 2. So now I have two equations. I need to know where is arc sine of root 3 over 2, as well as arc sine of minus root 3 over 2. Well, once again, let's think about at least a little bit of my unit circle. Up here at pi over 3, we have the point 1/2 comma root 3 over 2. So for this first equation, we can see that x is equal to pi over 3. For negative root 3 over 2, that point is going to be down here where the y-coordinate is negative. So we are going to need to go down, in other words, negative pi over 3. So this one has two solutions, pi over 3 and negative pi over 3. Next, let's look at 2 cosine x sine x equal to cosine x. This seems a little bit tricky, so I'm going to start by actually just subtracting cosine x from both sides to get everything on one side. That gives me 2 cosine x sine x minus cosine x. And from here I can actually factor. I can factor out a cosine. When I do, I get 2 sine x minus 1. Well, now my zero product property tells me that either cosine of x is equal to 0 or 2 sine x minus 1 is equal to 0. Adding 1 gives me 2 sine x equal to 1, and dividing by 2, you get sine of x is equal to 1/2. We can use our unit circle to see that cosine of x is equal to 0 when x is pi over 2, so that'll be the first equation here. My second one, once again, we can use my unit circle to see that sine of pi over 6 is 1/2. So my two solutions are pi over 2 and pi over 6.